So, talking about quadratic probing, it is something where instead of searching for the immediate next slot, we will jump onto some two gaps or three gaps slot. So, we'll just leave some gaps and then we will search for the next empty slot that we get. The reason for doing this particular technique, implementing this, will be in most of the cases, it may happen that the immediate next slots are also occupied. In such a case, the best case to get or there is more chance that we can get an empty slot if we just just leave some gaps and move on to the next available slot. So there is more chance, more probability of getting an empty slot if we jump and we search for the next slot instead of just moving to the neighboring slot. So that is why this technique got evolved. So if we face any limitations with linear probing where the immediate slots can also be full, this is the technique that can work faster than linear probing. So let's see how to do this. So here we have this table size of 10 and you can clearly see that the values are very clearly mentioned, and there is 10, 20, 30. Obviously all these three will be generating the same index. So there is definitely happening a collision. In such a case, if I use a linear probing, I can see that for 10 index 0 is occupied. So for 20 I'll get the next slot available. For 30 I'll get the next slot. But then when I'll move to 81, it will generate index 1 which will be already occupied. So in such a case, again if I go for next slot, that is also occupied. So the best way is to jump by just keeping some gaps in between. So it will help me to get more probability of getting an empty slot. So let's see how to do this particular technique. So again there is a formula and it is easier to do. Again in the solution we will start with division method, which is our default hash function we are going to use. So as per the division method, the formula is h of x mod table size. Now our first value is h of 10 mod 10 resulting to index 0, h of 20 mod 10 resulting to index 0 again. Now since we have got the same index, we will say that collision occurred. And now since there is a collision, we will apply quadratic probing as mentioned. So the formula for quadratic probing is hi of x equal to h plus I square, as the name itself tells quadratic. So we have to do I square mod table size. So again you will see that it is somewhat similar to linear probe. It's just that instead of getting the next slot, we are just jumping to the square value. Okay, so that is how it will be performed. So we will do h1 of 20. So 20 plus 1 square mod 10. Now 1 square is 1, so 21 mod 10 will be index 1, which is empty, so we'll use this. Then we'll move to next value, h of 30, which we'll do by the normal formula, giving us again a collision. So I'm saying collision has occurred. I'm not repeating the formula again, as now you have understood the formula. We will directly go with h1 of 30. 30 plus 1 square mod 10. Now you can see that the slot is already occupied. If we are getting index 1, it is occupied. So we'll do h2 of 30. Now it will do 30 plus 2 square mod 10. So 2 square is 4. So it should generate index 4. Now this is the benefit we are having here, that when I'm doing this, I'm getting an empty slot, because again there may be possibility that slot 2 is also full. In this case it is not, but there may be a possibility. So just moving to 4 will be an easier chance to get an empty slot. So here this will be the final value. Moving to the next, h of 81, 81 mod 10, we will get index 1, which is again a collision. So again we have to apply the quadratic probing. So we'll do h1 of 81, 81 plus 1 square mod 10. So 81 plus 1 square will be 82, generating index 2, and 2 is not in use, so we can use it, right? So I don't need to do it twice for 81, which is good. I need to move to next value, 82. Now here again we are getting a collision, as it will generate index 2, which is already in use. So collision, and since there is a collision, we will do h1 of 82, doing 82 plus 1 square mod 10, which is 3. 3 is not in use, so we can use it. So now we have got covered all the values with all the unique indices, and we are done with our hashing with quadratic probing. So now we will simply create a hash table and we'll put all the values in it. Let's just create it here itself. So the hash table will be, we have all these indices, and now we'll just go by index. So for 0 index we have value 10, for index 1 we have value 20, for index 4 we have value 30, for index 2 we have 81, and for index 3 we have 82. You can see that there are no gaps as well. The values are filled in well, and also there was very much more of a chance to get an empty slot, because the calculation had some is just keeping some gaps, and that is just giving us more chances to get an empty slot. So this is how we can do quadratic probing, and it works faster than linear probing. Now we'll see the next technique, which is rehashing. We'll see why it is required and how to do it.